when you're rubbing one body with another body, electrons are transferred from one object to what? Another object. Okay, this process, this type of electricity is been given a name.
Halogen connected carbon sp3, then it's connected to benzene. See all of you, halogen connected. What is this carbon hybridization? Full single bond sp3, see then a benzene ring.
Denominator poles shouldn't be included in the denominator poles. That means the denominator, these -1 and -5 should never be included in the solution.
Homocircle caudal fin. It's giving two equal lobes. But in case of cartilage fishes, look at here, one big lobe is there, one small lobe is there. You cannot cut into two equal half this fin.
Good evening, dear students. Today, as we know, we are going to explain the current electricity important numericals. You know why we are focusing on MCQs and assertion reason questions? Even many of our students, they wrote the pre-board 1 and pre-board 2. When we are checking their answer sheet, it is clear that see, they are losing mark in MCQs. Most of the students are, out of this 16, they are clearing only 8, someone cleared 7. Very less students only, they are scoring above 10. So, that is out of 16, I'm saying. So, it is very important MCQs and assertion reason questions. Today, we are doing current electricity. Current electricity is a confusing chapter and there are many concepts are there. So, let us go. And we are ready to solve the MCQs. So the first question, see there, current electricity, that we are explaining the first question. This first question is actually based on the resistivity versus temperature idea. That is temperature depends of resistivity of a material A and material B is represented by figure 1 and figure 2 respectively. Identify the material A and material B. We know when we are considering this resistivity variation in NCERT textbook, there is 3 graphs are there. These 3 graphs are very, very important. What is the graph now? First one, for conductors, that means in the case of conductors, especially for metals, this resistivity versus temperature graph will be like this for metals. And for alloys means that is a combination of metals. So we can say this graph is coming, rho T graph will be a straight line. So it is for alloys. The second graph is for alloys. And for insulators and semiconductors, this graph is coming like this. So now for semiconductors, the rho T graph is coming like this. So we can say this variation of resistivity with the temperature is different for different type of materials. Metals means everyone know example, copper, if I am considering silver, aluminum are examples. Alloys, alloys examples are there, alloy if I am considering, that is a constantan, and manganine, and nichrome are some examples of this one, alloys. And semiconductors, the two very famous examples that we know, germanium and silicon. So semiconductor, germanium and silicon is there. So look at the graph now what they are given. So first case, the figure 1 is for semiconductor. So material A is germanium, no doubt, because germanium is a semiconductor. And next one, so now this one is a metal. So material B is copper. So that is also correct only. So we can say that actually option B, the right one, that is material A is germanium and material B is copper. So that's the right picture, I think. Okay. Now there are many students, they are answering, see this one correctly. Reem is there and Mahak is there, and King Paper Ball is there. Many are there like that. See, and Smriti is there. Okay. So it's a clear answer. Many of them give the right answer correctly, and that is equal to option B. Option B, the right one. See the next question. Look, an electric current is passed through a circuit containing two wires of same materials connected in parallel. If the length and radii of the wires are in the ratio 3:2 and 2:3, then they are asking find the ratio of the current passing through the wire will be. First of all, see in this question, they are connected in parallel. Connected in parallel means voltage remains the same. We know the formula, I is equal to V by R. So voltage is same. So I can say that is I1 divided by I2 is equal to R2 divided by R1, as they are inversely proportional to resistance. I1 by I2 equal to R2 by R1 is there. This R we can calculate. So what is the picture here? R is equal to rho L by A is there. So I can say rho L by A, but here they are giving the radius is given. Look, in this question, length and radii. So I can write rho L divided by pi R square. Rho L by pi R square. Now here, suppose I am writing R2 by R1. So I want to find first R2 by R1 ratio. So same material and pi will be not coming. So I can write L2 by L1 into, as it is inversely proportional here, R1 square divided by R2 square is there. Now L2 by L1 I need. Take care, here the length ratio given 3:2. So that 3:2 means L1 by L2 ratio. So L2 by L1 means it is 2 by 3. So we can say 2 by 3 into. Now R1 by R2 ratio is there. Here R1 R2 ratio given in this one, that is equal to 2:3. So that I am writing 2:3 is the R1 by R2, but I need R1 square by R2 square. So 2 square divided by 3 square is there. So 2 into 2 square is 8 and 3 into 3 square is 27. So the ratio is 8:27 is there. Ratio is 8:27. Many are there, see, supporting the answers, like that, and it's good. So we can say manganese. Someone is asking what is manganese. Manganese is an alloy. Constantan is also an alloy. So these two alloys name is explained in the textbook. So please study this one, manganese and constantan. They are using to prepare standard resistance coils. Okay. Now we can say correctly here this one, that is 8:27 is there. Yes, right. So the right answer is 8:27. See, the right answer is there. See. So now there we are trying the next question. Now look. By increasing the temperature, the specific resistance of a conductor and a semiconductor is same question as before. They asked in terms of graph, and here it is clearly by a statement. What is specific resistance? Dear students, specific resistance is resistivity. Specific resistance means that is resistivity. Now we can say how they are changing. So in the case of a conductor, we can see that it increases for a conductor and it decreases for a semiconductor. Increases for a conductor and decreases for a semiconductor is there. So we can say the right answer is option C. Option C, the right answer is coming. Now the next question that we are trying. So look, question fourth one. Look, what's this question? We use alloys for making standard resistors because, do you remember we said what standard resistors are made by manganese or constantan? They are alloys. Why they are alloys are preferred to make standard resistance or meter bridge wire or potentiometer wire. So there is, the reason is that, you know, look, first point, standard resistance have, or we can say alloys have low temperature coefficient of resistance, low alpha value, that we know. And the second one, so suppose we are considering, you know, in the case of alloys, they have high resistivity also. High resistivity also. So that is why these two reasons. So low temperature coefficient of resistivity and high specific resistance. So which one is coming? Low temperature coefficient of resistivity and high specific resistance is there. So we can say option A, the right one. So that is why when we are sketching the roti graph, again that question is repeating. There, that question is that much important. You know, when we are sketching the roti graph for alloys, there we are starting our graph something above that is, you know, see from y-axis. A little height we are giving. So what's the point there means resistivity is high. But in the case of conductor, when we are sketching this roti graph, you know, see, we are drawing this graph. So it is quite low and here it is quite high. So we can say that correctly. In the case of, if you are considering alloys, we can say they have a low alpha value and we can say that is the high resistivity is there. There are Ania Khan and Pooja and Sharon, okay, Reem, Mahak and King Paper Ball, Abu Muhammad and Edits, I think, you know, see. So these all, so we can say that correctly, the important, you know, the question that we explained correctly. Thank you for your support and thank you for your active participations. Many are there in the viewers, you know, see, please come and support and comment on the chat box. Now there, next question we are explaining. A constant voltage is applied between the two ends of a uniform metallic wire. Heat H is developed in it. If another wire of the same material, double the radius and twice the length as compared to original wire is used, then the heat developed in it will be. So here, you know, the question is heat developed. Heat developed. For heat developed, which equation we studied? Dear, you know, we studied H equal to I square RT. That we know, heat developed. Dear, we know that is, here that equation is not suitable because constant voltage is mentioned in the question. So, you know, that we can replace. So, this constant voltage, I need the expression in terms of constant voltage. So, heat is equal to, I am going to replace I equal to V by R. So, we can say V square by R square into RT is there. So, this cancels. So, V square by RT. V square by RT. There, here voltage is not changing. Time is not changing. So what we can say means, you know, that is heat generated is inversely proportional to resistance. You know, this resistance I can write. So I am writing now, please see, H1 by H2 is equal to R2 by R1 is there because they are inversely proportional. Now here this R2 and R1 value we can find by using this idea. Look, here they are saying same. Now what is the resistance formula? R equal to rho L by A. Here same material, so rho will be same. And we can say double the radius and twice the length. So I want to write this in terms of radius now. So rho L divided by pi R square is there. So R2 I am going to write now. So please see rho 2L because double the length divided by and pi into 2R the whole square because double the radius divided by rho L by pi R square is there. So I can write H1 by H2 is equal to, here rho L, if I am considering the terms here, rho L cancel, pi cancel, R square cancels, 2 by 2 square is there. So I am writing that is 2 by 2 square, that is equal to 1 by 2. So H2 is equal to 2H1 is there. H2 is 2H1. So we can say that heat doubled. So the right answer is option C, that is equal to 2H. Many are there. They are giving in the chat box the right answer. It's right, it's promising, it's a challenging. So we can say that is the option C, the right one. That is 2H is the right answer is coming. 2H, the heat generated will be. So here I am repeating once more, dear students, when we are finding the heat generated in the wire, we have I square RT formula, V square by RT formula, constant voltage is given. So we are doing V square by RT formula. Now the next question, please look. If the potential difference we applied across a conductor is increased to 2V with its temperature kept constant, then here there is an addition in the question, a correction in the question, then the drift velocity of free electron. Drift velocity of free electron in a conductor. That's the question. Drift velocity of the heat is generating. Thank you dear. So look, so we can say, look, heat, so we can, the drift velocity of the free electron in a conductor is, that we want to calculate. Dear, in order to find the drift velocity, constant potential voltage given, do you know we have the drift velocity formula? Drift velocity, we studied three formulas. What are the equations? I by NAE. Next one, VD equal to, we studied, EV tau by ML. And the basic formula that we have, VD is equal to EE tau by M. Three formulas. These three formulas are actually for the three cases. So here they are saying that is the constant voltage only changing, voltage doubled. So voltage changing means I want to use this formula only. Mass and length, they are not saying anything. Temperature is constant, E is charge of electron. So we can say VD is directly proportional to applied potential voltage. Applied potential difference. So we can say that is B double of its initial value. So right answer is C. So we can say the right answer is C here because it is double of its initial value. Okay. Now see, recall this idea. One point, this will never repeat again. This will never repeat again. March 4th in exam hall. So dear, recall drift velocity, three formulas. For constant current, my dear students, for constant current, use this equation. For constant voltage, use this formula. EV tau by ML. Let us see now the next question. Look, a battery is connected to a conductor. of non-uniform cross-section area, the quantities or quantity which remains a constant is. You know, here which quantity remains the constant, that we are going to explain. So here, you know, whether electric field constant, and whether drift speed and electric field constant, electric field and current constant, or current only constant, we can verify. First of all, you know, in the case of drift speed, current is mentioned. Look, a battery is connected to the conductor, the quantities which remains the same. You know, drift velocity, we know the formula I by NAE. So we can say area of cross section is different, so drift velocity will be different. That's clear. And next one, dear, when I am considering the next one, electric field, you know the formula J equal to sigma E. So we can say E is equal to J by sigma. You know, when area changes, J will change. When area changes, J will change. Why? Because J equal to I by A. So J changes when area changes. Then what's the picture here correctly? J changes means electric field also changes. So we can say electric field is also not constant. Then we can say the current is constant here. So the right answer is option D, current only. I am repeating, this question is NCERT backside question and it is important. In a given wire, the current is independent of cross-sectional area. In a given wire, current is independent of cross-sectional area. Cross-sectional area. Yes, Venkada and King Yunusi, Dates Mahak and Muhammad Hisham, Reem, Abu Muhammad, everyone, you know, see, they are supporting, you know, so the right answer, that is option D, that is current only coming, current only. Okay, now the next one, the next question, look. This question is a tricky question, please see. Three resistors, R1, R2 and R3 are connected in series to a battery. Suppose R1 carries a current of 2 ampere, R2 has a resistance of 3 ohm and R3 dissipates 6 watts of power, then the voltage across R3 is there. So here we are drawing the circuit here, 3 resistors connected in series. So this is R1, this is R2, this is R3. Now what they are saying means, you know, look here, the R1 carries current 2 ampere. So I am marking here the current is 2 ampere. There, if R1 carries current 2 ampere, R2 also, R3 also carries current 2 ampere only. Because in series current remains the same. So here also current 2 ampere. Here also the current is 2 ampere. Then they give another data. R2 has a resistance 3 ohm. So we can say R2 is equal to 3 ohm is there. Then R3 dissipates 6 watt of power. So the power across R3 is given, that is equal to 6 watt. You know what is the formula for power here? Power is equal to I square R, that we know. Power is I square R. So we can say that is clearly the I square R is equal to 6. Sir, why I square R? Current is same. Series connection. So we can say I square R is there. Now here I value we already given. So what is that? 2. So 2 square R3 is equal to 6. So R3 is equal to 6 by 2 square, 6 by 4, that is equal to 3 by 2, 1.5 ohm. There, but that resistance is not the, they are asking what is the voltage across the R3, voltage across. So we know we got a R3 now. So voltage across R3 is I into R3. So I value is there already 2. I same, R3 you calculated 1.5. So that is equal to 3 volt. So the voltage across R3 is 3 volt. So option C, the right answer is there. Is right. Option C, the right answer is coming. Currently, see, that is here in this picture, the 3 data is given for 3 resistors. From there we are deducing, power is equal to I square R. I want to use here. So that is the formula. So V3 is equal to 3V. Next one, again graph question is coming in current electricity. There, this graph question we repeated in our classroom many times, very important. There, look, a straight line plot showing the terminal potential difference of a cell as a function of current drawn from it. Its internal resistance of the cell would be then 2.8, 1.4, 1.2 and 0 is there. This VI graph has 2 properties. So this night we are studying. For those they are not recalling them, we are revising. So the cell graph, cell graph, the voltage versus current graph across a cell, VI graph. I am repeating, VI graph across a cell and across a conductor different. VI graph across a cell and across a conductor is different. We know this is across a cell. This is across a cell. VI graph is there. What are the data we are getting from this graph? The y-intercept of the graph, that is the y-intercept of the graph gives EMF. Y-intercept is EMF, and we can say the slope of the graph gives internal resistance. So we can say, if they are asking what is the EMF of the cell, we'll say 5.6. And what is the slope of the graph? Now how I can find the slope? Slope equal to rise by run. So we can say y by x. So I'm taking, that is 5.6 by 2. 5.6 by 2 is equal to 2.8. So that we can say the internal resistance R equal to 2.8 ohm is coming. 2.8 ohm. There I'm repeating once more. See, recollect. Don't forget what I'm saying. Across a cell VI graph, then we know the y-intercept of the graph is equal to EMF. The slope of the graph equal to internal resistance. So to find internal resistance, we are finding slope. So some students may have doubt, sir, here slope is negative, then why we are not taking negative sign? Resistance is not negative. So we don't want negative. So for those we can write the magnitude of the slope is equal to internal resistance. It is actually, if we find minus also, minus answer is not coming. Resistance can never be negative. So we can say, yes, Chris, right. The right answer is option A, 2.8 ohm is the right answer. Okay, now we are explaining the next question. Now look, it's an assertion reason question. Their assertion reason question, first one, the conductivity of intrinsic semiconductor. Conductivity of intrinsic semiconductor increases with an increase in temperature. Okay, now increase in temperature decreases the average time between collisions of electrons. There, the first statement is correct only. In the case of an intrinsic semiconductor, the conductivity increases, that is with the increase in temperature. You know the formula, the conductivity formula, sigma is equal to, we know that is, we studied the formula for rho and then sigma. Sigma is equal to n e square tau. I'm explaining the point there. You studied R equal to ml divided by n a e square tau. Just recalling, that's why we are writing. R, rho is equal to, tell me in your mind, then you can recall everyone. So listen here, that is m divided by n e square tau is there. Reciprocal is conductivity. So n e square tau divided by m. Okay. Now, but there is in the reason there is a problem. What's the problem? Look, increase in temperature decreases the average time between collisions of electrons. Look, when we are increasing temperature, it's very clear. When we are increasing temperature, time interval between collision is decreasing. Okay, when we are increasing temperature, tau value will decrease. But still, you know that is why sigma is increasing. The reason is that when we are increasing temperature, in the case of a semiconductor, electrons are moving from valence band to conduction band. So, number density of free electron increases. And then we wrote in our notebook very correctly, the increase in number density is more than the decrease in tau. So that is why we can say sigma increases. So correct question. So conceptual question. I am repeating once more. What's the point there? Look, this is correct only. Reason is correct only. Increase in temperature decreases average time between collision of electron is correct only. But the problem that not justifying our assertion. So we can say assertion is correct, reason also correct, but we can say that is the correct one is the reason is not the correct explanation of assertion. So in our CBSE pattern, it is option B. Option B is coming. Yes, many are there. Muhammad Ibrahim and Mahak, and we can say there are many they answered correctly. That is, see this picture, that is option B the right one. Option B the right one. Assertion reason question, read 2-3 times, then only answer the question. Okay, there now the next one. The electron drift speed is so small and the electron's charge is also very small, but we still obtain large amount of current in a conductor, which is due to, drift speed is in the order of few millimeter per second, that we know correctly, very small, few millimeter per second. And we can say charge of electron is 10 raised to minus 19, very less, but still we are getting a large current. What's the reason? The current expression I equal to NVD. So here the drift speed is small, charge of electron is small, but still area of cross section is meaningless. For a copper wire, very thin wire, very negligible cross section, large current can flow. So what is the reason? Because there are large number of electrons per unit volume. How many it is? How much it is? There the rough calculation shows 10 raised to 28 per meter cube is the number density. Number density means number of free electrons per unit volume. Number of free electrons per unit volume is there. So we can say yes, Nayan Thambi, right answer. So we can say that is Smridhi, right one. So Mini Reem, right one. So we can say the right answer is option C. Electron number density is the right one. Electron number density. Okay. Now the next question, look. The network shown in the figure is part of a complete circuit. If at a certain instant the current I is 5 ampere and is decreasing at a rate of here 10 raised to 3 ampere per second, then what is the potential difference between the points A and B? That's the question. So dear, we have to find the potential difference between A and B. This year JE, a question came like that. And this is a previous year question also. So look, it's a possible question. So there I'm explaining once more. Look, so I want to find potential difference between A and B. Look, I'm starting with A. So we can say, suppose the potential difference at the point A is VA. When I am moving through, listen here, when I am moving through this resistor, what happens? Some voltage drops. Some voltage drops. How much is the voltage drop? IR. So current is given 5. Resistance is 1. So minus 5 into 1. Then when I am crossing this cell now, minus to plus, so we can say there is an addition of voltage. So I can write plus 15, plus 15. Then we are going across the inductor. When we are going through the inductor, we studied current changes at the rate. We know when current changes at the rate, an EMF is induced in the inductor. One more point, that EMF opposes the growth of current. So it drops only. So we can say how much that EMF induced in an inductor. E is equal to, we know, minus L di by dt. EMF induced in this one is minus L di by dt is there. So I can write that is minus L value given here, 5 into 10 raised to minus 3. Di by dt given 10 raised to 3. So into 10 raised to 3 is there. So that is minus 5. So we can say minus 5 is equal to VB is there. That is VB. Now we can take, listen here, VA minus 5 minus 10 plus 15 equal to VB. So VA plus 5 equal to VB. So VA minus VB equal to minus 5. VA minus VB equal to minus 5. So the potential difference is coming minus 5. So I'm repeating once more. Please listen here. Simple idea. Look there, see, I'm repeating once more. This one correctly. Look, we are starting from the point A and reaching on the point B. So when we are starting, the potential at the point A, VA, minus the voltage across that is 5 into 1. Then across the battery, there is a gain now. So plus 15. Again across the inductor, it drops. So minus L di by dt is there. So we can say the right answer is coming. That is equal to option C. That is minus 5 volt is there, minus 5. There now, the next one. So the next question, please see. The resistance of a metal wire increases with the increasing temperature on account of metal wire. So this word is important. It's a metal wire. What is the formula for resistance? ML divided by NA E square tau. So here can you say on account of what this resistance is increasing? When temperature increases, we can say number of collision increases. Number of collision increases. If number of collision increases, time interval between two successive collision decreases. So we can say tau value decreases. So when tau decreases, resistance increases. Dear, the same question, see, this is for metal wire. The same question, if they are asking for a semiconductor, then what is our answer? It is not because of this decrease in relaxation time. It is due to the increase in number density of free electron. Okay, so that point you have to keep. Already we explained one question like that. So these points are very important in our board examination. There now look, resistance of a given conductor depends upon temperature, length, area, shape of the conductor. Already everyone knows it depends only on temperature. It is not depends on length, not depends on area, not depends on shape. So resistivity depends only on temperature. So we can say there is someone is there, G, no, we don't know the name correctly. So Siddharth is there. Okay, many are there, see. Okay, correct. So the right answer is here. That is option A. That is temperature, resistivity. And the next one, look. Consider a current carrying wire. Exemplar question it is. exemplar. So now there are some students asking whether exemplar questions we want to study. Their NCERT exemplar questions, they are little higher level questions, but you should have an idea about that. That is important. For those they are aiming above 65, must go through exemplar questions. Here look, consider a current carrying wire in the shape of a circle. Note that as the current progresses along the wire, the direction of J changes in exact manner, while the current I remains unaffected. The agent that is essentially responsible for is, actually here the source of current, here source of current only, or source of EMF, that is actually it's a source of EMF. And the next one, that is electric field produced by charges accumulated on the surface of the wire. Charges just behind a given segment, charges ahead. You know one thing, see this answer is very logic, because a charge can deflect the flow of electron with the help of the electric field produced by that charge only. I am repeating once more. Look, if there is a charge, in order to experience a deflection, there should be a force. Of course, no? There should be a force. So that force will be generated only in the presence of electric field. So they are saying the picture here currently, there is the direction changes. So it's clear, when there is change in direction, we know the point, listen here, when there is change in direction, look, direction changes. There please see, direction changes means there should be a force. There should be a force. Force will be generated only with the help of electric field. So we can say F is equal to QE. So there should be an electric field to change the direction of force. I think you got it. Okay, so the right answer is option B. Option B, the right answer, electric field produced by charges accumulated on the surface of wire. On the surface of wire. Next one, look, two batteries of EMF, E1 and E2. Yes, dear, see, thank you for your support. Now listen here, look, two batteries of EMF, E1 and E2, and internal resistance R1 and R2 respectively are connected in parallel as shown in the figure. They are connected parallelly. Then what about the equivalent EMF? You remember, when the cells are connected in parallel, the equivalent EMF, we have a formula. What is that? E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2 is the formula. That's the formula for equivalent EMF. You know one thing. So look, so what's the point here means, you can see here this equivalent EMF, they said E2 greater than E1. So equivalent EMF should lies between E1 and E2. It should be less than E2 and it should be more than E1. So the right answer is correctly option A, that is E1 less than E equivalent less than E2 is there correctly. Okay. There, now the next one, next question, look. The drift velocity of the free electron in a conducting wire carrying a current I is V. If in a wire of the same metal but of double the radius, the current be 2I, it's 2I, then the drift velocity of the electron will be, look again the idea current. So can you say which formula we will use? I by NAE formula. So we can say VD is equal to I by NAE is there. And here look, the second case current is 2I. So VD dash is equal to 2I by N. Look, radius doubled. Radius doubled. Radius doubled means area increases by 4 times, because we know the point. Area is equal to pi r square. So new area pi into 2r the whole square So pi 4r square. So 4 times the area is coming. So 4 times the area into E is there. Now here we can say we are cancelling the terms now correctly. This 2 and 4 we are cancelling. So denominator 2 will be there. So we can say that is equal to I by 2 and AE is there. That is equal to V by 2. V by 2. So it decreases by 2 times. Yes, right. So we can say the answer. Om Patel right, Smriti Ganesh right, Ray Mahak, and see everyone right the right answer correctly, and that is equal to yes, Vangada right. So we can say the option B the right one. The next question, look, the element of a heater is rated PV. If it is connected across a source of voltage V by 2, then the power consumed will be by it will be. That's the question. So I'm repeating the question. Listen here, look. The element of a heater is rated PV. So what is the meaning of that? When the voltage is V, the power is P. That's the meaning. When voltage is V, the power is P. So we have the formula P equal to V square by R, because we mentioned correctly. Now dear, next one. When the voltage is V by 2, what is the power? Resistance is not changing. Na? So we can say P dash is equal to V by 2 the all square divided by R is there. So that is equal to V square by 4R. V square by R is P. So it is P by 4. So the right answer is option D. That is equal to P by 4. The power is equal to P by 4 is there. Power is P by 4. Okay. Now the next one. A cell of internal resistance R is connected across an external resistance capital R can supply maximum current when. Here there is a twist. Listen here, I will explain. We have the formula I is equal to E by R plus R. I need a current maximum. So we can say when current is maximum, look, this external resistance is least. So that is inversely. So R equal to 0. But there is another point also. That point additional one. Please listen here. If power is maximum, power consumed by the device maximum. So power consumed by the device maximum means no device is possible having external resistance 0. So that point I am highlighting here. Hopefully it is a very important concept. Listen here. If in the same question, if power is maximum, then capital R is equal to small r is coming. For constant maximum power, capital R and small r will be equal. Otherwise, see, that is the picture now. I think you got it correctly. So we can say here current maximum. So in external resistance is 0. Now the next one. The ratio of current density and electric field. What is the picture for current density and electric field? The formula J equal to sigma E. So we can say sigma is equal to the ratio of current density to the electric field. So J by E is equal to conductivity. So I'm saying, even one of my best student, made error in the examination. So because the question is just reverse. The ratio of electric field to current density. Another set. What the problem means, not writing that. Just think by mind. So the formula J equal to sigma E. So okay, mind came sigma is the answer. But look, it is reverse. So in such ratios questions, I am requesting to all of you, there please write the equation. In your answer sheet, write the equation and verify. If you are concluding like that, never we will went wrong. So the answer here, conductivity. There, next one, electrical resistance of a conductor varies directly proportional, decreases with increase in temperature, decreases with increase in conductivity, independent of its shape, but depends only on its volume. There, resistance R equal to rho L by A. So, varies directly proportional to area of cross section, wrong. Then conductor, it no decreases with increase in temperature, that is also wrong. Decreases with increase in its conductivity, that is correct only. When conductivity increases, then we can say an independent of its shape, but depends only on its volume. Their length and area actually measured of volume only there. So we can say here the right answer is D, independent on its shape, but depends only on its volume. So if the constant volume is there correctly, LA is the picture now. There, now next one, the last two more questions are there correctly, please see. Look there, the question, for a fixed potential difference applied across a conductor, the drift speed of free electrons does not depends upon, look, fixed potential difference, fixed voltage. So which formula? VD equal to, please there, EV tau by ML. EV tau by ML. So here we can say it is not depends upon, look here, length depends, and we can say mass of electron depends, temperature depends. So it is no depends on the free electron density in the conductor. So we can say the right answer is here A, that is look, free electron density in the conductor. This question also there is a problem. So look, students may think like that, sir, here VD equal to I by NAE, where area depends. Then look, then we are saying what's the problem? Number density depends. Then why it is? Look, fixed potential they mentioned correctly. So this equation is not possible there. Wipe out from the mind. EV tau by ML only correct. So we are getting the formula that is correctly, see, now we can say free electron density in the conductor is there. There, the next question, a car battery, last question today, look, a car battery is charged by a 12 volt supply. Energy stored in it is given. The charge passed through the battery is, energy means work. Voltage is also given. How you will find the charge? There we know the formula, W is equal to QV is there. So we can say, we can calculate Q. Q is equal to W by V. So what is W? 7.2 into 10 raised to 5. What is V? That is equal to 12. So we are getting the answer 6 into 10 raised to 4 coulomb is there. 10 raised to 4 coulomb. So there are some more questions. As time is not permitting, we are winding up the session now. So I'm requesting to all of you. I know all the students who are hearing me are working hard. So we have very less days are remaining. So work correctly, smart work. It will give you a very good mark in the board examination. Wish you all a colorful mark in physics and especially in all subjects in board examination. Thank you dear. Thank you all.